Hi folks, welcome to the channel. My name's Colin, call sign MM0OPX. In front of you here, you can see two 49-to-1 transformers. These are probably the most common end-fed half-wave transformers you're going to see, either making yourself or buying commercially. One on the left here is a FT140-43, so it's 43 type material. And one on the right here is an FT240-43. So it's the same material for both, they're just physically different sizes of cores. So they both have two primary windings wound together and 14 secondary windings, which gives us an impedance transformation of 49-to-1. And the purpose of this video is to actually see how much power these can really handle. Now, this video is not designed to be totally scientific. You're going to have to take a pinch of salt with this. I just don't have enough time to test for hours and hours and hours, so I'm going to try and get these to fail quite quickly. Both of these are obviously made by myself. The test conditions are going to be, I'm going to use 20 meters. Now, unfortunately, due to the size of my garden, so how I'm going to set things up is as follows. These transformers will be approximately 1.5 meters, 2 meters from the ground. So elevated feed point. It's going to have a vertical wire approximately 10 meters, and that's going to give us our half wave on 20 meters. And we're going to basically run power, start off low and then gradually get more and more, and we're going to look for the point where the SWR just starts to rise, and at that point we know that this core is reaching the curry point or the Curie point where it loses its properties, basically. Again, I think the efficiency of these cores will start to degrade as they heat up before they hit that point. I can't test that just now. I've got a method in my mind to do that, but basically the test will end once the SWR starts to rise at all with these cores. I'm going to run FT8. So I'm saying full duty cycles, so what's that, 15, 16 seconds on, 15, 16 seconds off. So full duty cycle in my mind is running, say, one of the PSK modes or RTTY, where you've got long overs. So let's go and have a look at, we're going to test the FT140-43 first. So let's go and see the setup with that. So this is the 49-to-1. Made from the FT140-43. So we've got it set up here on my 12 meter spider beam pole, and there's approximately a 10 meter length of wire all the way up to top there. So that's the setup. So there's a small piece. This is Messi and Poloni. I think it's this Hyperflex crystal. This runs back a little ways. Runs back to here. This is the GM3 ACK choke. And there's another little patch cable which takes it back to the analyzer. So if we do a sweep, now it's not perfect, but it's more than good enough. You can see that the SWR is well down. So down in the FT8 portion of the band, it's going to be 1.2 or below. Now what I'm going to do is I'll now hook this up to my coax that goes back up to the shack, which is here. This is Messi and Poloni Ultraflex 7. There's about 16 meters of this, so there's a little bit of coax here, but losses are going to be pretty much insignificant, and we'll go and see how much power on FT8 this can handle. We're back in the shack here, and we've got the antenna hooked up to the radio. So you can see that we've got the radio set to 25 watts on the FT8 frequency, and WSGT is actually decoding, and we're starting to hear some stations, obviously from the PSK reporter, what I'm hearing. And there actually seems to be some DX in the band, because I could see there was a Papa Yankee there just a minute ago. So, and we're actually being spotted, sorry, we're here in Australia. You can see here VK3. So what I'm going to do is I'm going to pick a clear frequency, and I'm just going to start transmitting at 25 watts. And then I'm just going to watch the SWR on the radio here, meter here. We'll watch that, and we'll see if that starts to rise. And as soon as that starts to rise, that's when we'll stop things. So we're now just over 20 minutes in, and we've been running FT8 continually for that time. I've actually just changed the power to 35 watts. We had it set at 25. and I just want to stress it a little bit more now that we're 20 minutes in. But I have noticed something pretty strange. Just probably about 15 minutes in, the power here was actually starting to creep up, and I hadn't changed anything obviously here on the FT8. So something's, I think, certainly happening, but the SWR isn't going any higher yet. But obviously we need to get to the curry point, curie point before that seems to happen. So we're going to just keep running for another bit longer. We'll run for this 35 so 25 watts for 20 minutes, 35 watts for another 10 minutes, and then we'll up it again, and we'll see. Obviously it takes time for the core to heat up, so we're not going to go too hard, and we'll see where we end up. So we're now 30 minutes in. We've just actually put the power up to 50 watts, and we're seeing that this strange phenomenon again, where the power seems to be creeping up here, although nothing else is changing, and I think that's because something's happening in the transformer. And I did that on 25 watts as well. You can see that we're just over the 50 watts. I had that set right on the 50 watts here, and I've not touched anything since, so I sense that something's actually happening. So we're on this again, we're on this for a bit longer. Okay, so that's us. The SWR just started to creep just as we turned the power up to 75 watts. So at 11:02 it went to 75 watts, and that's when the SWR started to creep. So the transformer must be really pretty hot, and we'll go and look at that shortly as well and see if there's any damage to the box melting to the plastic. So that was quite an interesting test. Let's go and have a look at the transformer. It's about 5 minutes since the test, and I've brought the 49-to-1 in, and it's still just lukewarm still, so it's had a little bit of time to cool. And the good thing that you can see is there's actually not been any melting or anything like that to the box, so it's still in good condition. It's still a perfectly usable onion. So yeah, so I think what we'll do now is actually we'll get onto the FT240-43. Now it's the turn of the FT240-43 49-to-1 transformer, which we've got inside this box, which you've seen already. Again, exactly the same setup as the FT140-43. And we'll go back to the analyzer and we'll just do a little sweep of the SWR. And it's very similar to what it was for the 140-43. So you can see even at the bottom of the band we're still 1.2 to 1 down here. So let's go and run some FT8 with this. Back in the shack once again, and we are now running the FT240-43. Now you can see that I'm only running 10 watts here, but I'm not really. I'm actually running my ACOM 1000, and 10 watts drive from the radio is giving me 105 watts out. And the SWR is pretty much, it's pretty low. It's basically unreadable up here, or it's just because of obviously the little bit of coax we've got back to the shack here. So now we actually need to watch the SWR on the ACOM. So here we go. So there's the SWR 1-to-1. It was about 1.2 down at the down close to the antenna. Now I didn't see the point of starting off with 50 or 75 watts, so I just went straight to 100 watts. So we'll run it at that for say 20 minutes, and then we'll start to up it. But I think 100 watts is going to actually be more than enough for this, but we'll see. Right, and that's us reached our point of SWR change with the FT240-43. So what I actually done was, the bands are in very, very good shape. This is just the last half an hour, but you know, we're working all over the world, or being heard all over the world anyway. So we started with 100 watts. After 20 minutes we went to 150 watts with the ACOM here using it, so we're not stressing the finals, and the Kevin obviously only does 100 watts anyway. So yeah, so 20 minutes in we went to 150 watts. Half an hour in we went to 200 watts, and then 8 minutes later we had that SWR change there. So so I mean that was 38 minutes in total, going from 100 watts up to 200 watts, and that's when the SWR started to change. I was trying to make it fail quite quickly, and that was the whole purpose, you know, to test for, you know, it would take hours and hours and hours, you know, just running it at a certain power level, you know, just seeing what it does. But you know, say that's 38 minutes and it's failed. So it's certainly not a 200 watt core. It's probably not even a 100 watt core. So yeah, very interesting. Again, here is our transformer after it's been run. So again, this one failed after 38 minutes. And let me tell you, this thing is really, really hot. I can't touch this. Extremely hot. I don't have my temperature gauge handy, but well, I think we'll just leave the box off that. But the good thing is, it's not melted the box. It's just very hot. You know, it's not melted the. I think this is ABS plastic. It's got a relatively low melting point. At least it's not done that yet. So if it was allowed to cool, you know, I think it'd be perfectly good to use again. There you have it. I need to try and summarise this somehow. As you've seen with the test, it's not I wouldn't say it's a completely scientific process what I've done, but I think it gives you an indication of where to start anyway. So let's take a look at the 140-43 first. So we started with 25 watts. Now, I should say that my coax is about, total length of coax is probably about 25 meters, maybe not quite as much as that. It's good coax. Majority of that is Messiaen Poloni Ultraflex 7, and the remaining is, I think it's Hyperflex 5 crystal. Anyway, it's good coax, so there's not a lot of loss there, so you need to take that into account, and I've not accounted for that. So, you know, the power that we're running is the power that we've seen from either the radio or the amplifier. So we started running this for, you know, 25 watts on FT8, and I never missed a cycle. It was just continually on off, on off, on off, all the way through. So we run that for 20 minutes, and then I raised the power to 35 watts. And in 10 minutes again, I raised the power to 50 watts. And in 10 minutes at the back of that, so that would be 40 minutes in, we raised it to 75 watts. And then another 8 minutes later, actually the SWR started to rise. So all told, it was just shy of 50 minutes, 48 minutes that we actually got this to fail. So if I was going to do this test a bit more scientifically, I would just run at one power level, let the core completely become cool, and start from the next power level up. So, you know, we got the Curie point, or the SWR, started to rise at 75 watts, but in effect, that's where we got to fail. I think this is going to fail a lot less than that. So if you're asking me if I had to guess what this is rated at FT8, I'm going to say 35 to 40 watts. Now, obviously, this is going to take a lot more power short term. You could probably run 100 or 200 watts very short term. Say it's an emergency, you just need to make that contact very quickly. It's not going to be an issue. But if you like to run digital modes, you know, I would say around about 35-40 watts as much as you're going to want to run this in this configuration. And of course, you could run a different configuration of transformer. You could have a 3-turn primary and a 21-turn secondary, which is going to make it a bit more efficient on some bands. So then you could probably run a bit more power than that. But 35 to 40 watts is what I think, based on this test, what you can run. If we take a look at the FT240-43, now we had already done the previous test with the 140-43, so I started with the bar slightly higher, and I started with straight off at 100 watts. So we ran it for 20 minutes at 100 watts, and then we put the power up to 150 watts. 10 minutes again at the back of that, we went to 200 watts. And another 8 minutes later, the SWR started to rise. So it was a total time of 38 minutes. Now, if I was going to do this again, I would probably just run it at 100 watts and just see, actually, you know, run it for an hour or so and just see where it gets to. Do I think it could even handle 150 watts? No, I think 100 watts is where this is roughly. Obviously, I was using my radio to drive my amplifier, and the radio obviously goes up in 5 watt increments. So basically, the next increment from 100 was 150. So driving from 10 to 15, that's what I went to. So I couldn't just run it at 125, say. So yeah, so it failed at 200 watts, but I think, you know, 100 watts where this, you know, where this transformer is. Now, for reference sake, this is my improved, I call it the 100 watt transformer. Now, if you look at these two cores, effectively they are much the same mass. There's only 2 grams weight difference, and I can't remember in favour of which. But doing the back-to-back test, this core is much more efficient. This is a 215, so this is actually a 56-to-1. So I've actually done some testing with this. So testing I did with this was, I ran it for 35 minutes, 125 watts, and it was still touchable. We could run that. Later on that evening, I participated in, I think it was a European DX contest, and I ran for 4 hours continuously at 100 watts, and this transformer did not miss a beat. So I know for a fact that this is good. When I say it's good for digital modes, 100 watts, no problem at all. So really what I want to do now is I actually want to do a test with this, and I actually want to run the same test with this as what I run with this. Run it under exactly the same conditions, change the power at exactly the same points, and actually see what it feels, because if it lasts longer than this, then it tells me that, you know, it just confirms that this is a more efficient core, which I know anyway. So yeah, so I wouldn't say that it's a completely scientific experiment, but I just wanted to push these kind of quickly to the point of where they would actually start to fail. I wish I had more time. I wish I could try it on more bands, because depending how efficient the transformer is on different bands, you're probably going to find that it fails at different points. I've just picked 20 meters because I'm able to get that as a vertical up in my garden. So make as you will from that. You know, let me know below what you think. If you have either of these transformers, you know, let me know what kind of power you run. If you've been doing tests, you know, I would really like to know what you've actually been doing and how you found it and how much power do you run. Obviously I'm only running FT8, so if you're using SSB, you know, you can run a bit more power than that. Okay, once again, I'm babbling on more than really what I need to do. So if you found that useful, you know, please give me the thumbs up and hit that subscribe button, and that gives me the encouragement to make more videos like this. 73, and hopefully see you on the next one.